So when I show you this global temperature series from observations, and then we launch into this debate, is it anthropogenically forced or is it naturally driven, like a solar factor, we really need to keep in mind the key sentence from IPCC. And it says that what we're looking at is really since the mid-20th century, that this part, the warming since the mid-20th century, this part here at the end, that's where the detection and attribution has been done for the greenhouse warming. We're not talking about the full 20th century. And this is a very important separation, because when you go further back in time, greenhouse gases are less, and we come towards a period where it's purely naturally driven. And it's key to remember when we talk about global warming, it's not the whole 20th century, but it's this last component here. I'll come back to this. So from a paleo perspective, paleo in my view here is really just the last few hundred years and maybe a few thousand years that you can take, where we have a good spatial coverage of information. Not perfect, but we have enough information, both high resolution seasonal from tree rings, from ice cores, from corals, documentary data that help us to reconstruct climate in different areas and also integrate it over a hemisphere for at least 600–700 years, and then a little bit less good resolution another 2,000 years back. Then we go to maybe decadal resolution or a little less 50-year resolution, and we can cover pretty much the Holocene. What I'm focusing on is mostly this period where we have really annual type data. And what I'm trying to do is to give the connection, similar as Jack Eddy did now 30 years ago, to say the instrumental period at the very end, here is the perspective over the last few centuries that is hopefully an apple-to-apple comparison, so you have a continuum in there. What he did 30 years ago, where he essentially relaunched the whole contribution of the sun to climate question, he looked at the 11-year sunspot history that was available. He extended it and found that we have very nice records of the 11-year sunspot cycle. And then, as Judith mentioned, there's this modern minimum period, which goes from 1645 to about 1715, when essentially the sunspots disappeared. Like my mic just disappeared. Oh, there we're back. Thank you. The sunspots disappeared, but it was not that there were no observations. Galileo Galilei started in 1610 and documented these sunspots, and we have almost daily drawings where these sunspots were observed and how they rotated around the sun. And people then looked for these things, but about 1640, in the mid-1640s, they essentially disappeared. So the question, as Judith also posed, what does that mean for the solar irradiance? What does that mean for the activity of the sun? What Jack Eddy then did here in this paper in Science in 1976, he used another predictor in there as well, which is, as Judith also showed, carbon-14, which was measured in tree rings. It's well dated, and there is this correlation between carbon-14 variations and the envelope of the sunspots. The question is, how closely related is it to the solar irradiance? It's the only proxy that we have. And we can actually look at auroras, we can look at naked eye observations of sunspots. Sometimes they're so big you don't need a telescope to look at it. The Chinese records have documented, but they describe that there are, birds and crows in the sun and so on. And you can correlate the overall fluctuations of this with carbon-14, beryllium-10, or then the observed sunspot records. And what you realize is these big scale variations, where you have these minima, they're represented in all of these measures. So we believe that, although not perfect and not a direct measure of total solar irradiance, it's a measure of activity in general. And the question for us is particularly, how do we have to scale this? Jack Eddy did then not only a history of solar activity, but he put the best possible temperature record against that. And that was essentially the start of this sun-climate relation in the modern climate research world. So what he took is this blue line. What you see is 2 points on the globe. It's Paris and London. Estimates are available going back to about here from Hubert Lang. These are mostly winter temperatures. And what you see, or what he documented there, was that there is a very close relationship between the activity of the sun represented by these different solar indicators, and that temperature. What we would today do is, of course, shy away from going to 2 points and saying this should represent global climate. But these were the only long records that were really available. Nowadays, 30 years later, we're in a different world. And I'm going to try to focus on this a little bit. So we can reassess what Jack Eddy did 30 years ago now in a different context. I want to go through a slightly like a modeler's perspective, but with this historical context in mind. I want to start off with some things that Judith showed. 11-year cycle variations, where they show up, and how models possibly could represent these. We go to the vertical structure, and then try to go into the longer time scale. And I'm going to show you model results that are with the IPCC models. So not the very latest specialized models that can take some of these indirect effects of ozone in the dynamical stratosphere, but the ones that are used to give you this message that the current globe is warming and that it's anthropogenic, very likely anthropogenic, and that there is this ramp up into the future that would be associated with any of the scenarios that we have looked at. So it's going to be this type of model, and it has to be a test on these types of models to see the continuum from a naturally driven world to an overlap and then maybe into an anthropogenic world.